Hi children, today let us discuss chapter 5 data handling. What is meant by data? Data means nothing but the information collected for some purpose. A collected information is called data. Now what type of information we collect? Suppose if your math teacher conducted an exam, he will collect the marks of all the students and he records those marks in marks register. That information collected by your math teacher regarding your marks, that is said to be a data. Similarly, your physical education teacher, he collects the heights of the students of your class, suppose. Then it is also a data. What is the need of collecting the information or collecting the data? Suppose your math teacher collected your marks. What is the need? If he analyzes your marks, then he can understand how many students got good marks, how many students got below average marks. If he know how many students got less marks, then he asks you why you got less marks. Do you have any problem while understanding the lesson? Like that he will ask you. So to get better results, we need to analyze the data. So for that we collect the data. If he observes the marks directly which are in his register, the marks in the register, that is called raw data. That means it is not organized data. Unorganized data, that is called raw data. Sometimes it may be difficult to analyze the raw data. So then we can show the raw data in the form of pictures and graphs. What are those pictures or graphs? So those are 1. Pictographs, next bar graph, then other one is double bar graph. Then what is pictograph? Let us see. A pictograph is pictorial representation of data using symbols. That means the data represented in the form of pictures is called pictograph. So the data represented in the form of pictures, is called pictograph. Likewise, you see in the diagram, the data is represented in the form of cars, you see here. So this is a pictograph. Suppose a company produced some cars in July month and in August month and in September month. We can represent the data in the form of pictograph as in the figure. Here the car symbol represents 100 cars. So one symbol stands for 100 cars. Here if you observe in July, one full car is there, so it is for 100 cars, and another full car, that is for 100 cars, half car. So here you can see half car denotes 1 by 2 of 100. 1 by 2 of 100 means 50. So 100 plus 100 plus 50. So this is equal to 250. Now in August we have 3 cars, that each car represents 100 cars. So 100 plus 100 plus 100 equal to 300. What about in September? Here we have 4 cars. Each car stands for 100 cars. So 4 cars means 4 times 100, that is equal to 400 cars. So the company produced 400 cars in the month of September. In this way, we can represent the data in the form of pictures. So this is called pictograph. Now let us go to bar graph. What is a bar graph? A display of information. Information means nothing but data. The display of data using bars of uniform width, their heights being proportional to the respective values. Let me take one example and explain the bar graph. Suppose number of students in 6th class is 20 and in 7th class number of students so 30. Suppose in 8th class number of students is 35. Then we can represent this data in the form of a bar graph. Let me take one horizontal line and vertical line like this. In the horizontal line, let us take classes. And on vertical line, let us take number of students. Number of students. Now here on vertical line, let us write this one as 10, this one as 20, and this is 30, and this is 40, suppose. Now what are the classes we have? We have 6th class, 7th class, 8th class. For each class, let us take uniform width. You see here, uniform width. And then in 6th class, how many students are there? 20 students are there. So we can draw like this. This rectangle represents 6th class students and the number equal to how much? Number of students equal to how much? 20. Now in 7th class, how many students are there? 30 students are there. Now let us draw like this. 30 students are there. So let us draw like this. So here width of these two rectangles must be same. First rectangle is of 6th class students. Now this is 7th class students. So how many students are there? 30 students are there. So this is 30 and this is 20. Now for 8th class students, how many students are there? 35 students are there. So now let us draw a graph like this. Suppose here is 35. Here is 35. Now let us draw the graph like this. This is of 8th class. And how many students are there in the class? 35 students. Now here, if you observe this diagram, it is in the form of bars with uniform width and the heights being proportional to the respective values. This is what we say bar graph. Now let us go to double bar graph. What is a double bar graph? A bar graph showing two sets of data simultaneously. It is useful for the comparison of data. So that means whenever we need to compare two data, we draw this graph. Here in the diagram you see there in 2005 and 6 and 2006 and 7 in some subjects maths, social science, science, English and Hindi, marks obtained by a student are shown in the graph. Now this empty, that means white one, that is the marks in the year 2005 and 6. Suppose if we take in maths, this is 30 and this is 60. That means in 2005-6, a student got how many marks? 30 marks. And in 2006-7, same student got 60 marks. Like that, if you want to compare two datas, then we use this graph. This is also a bar graph, but this bar graph shows two sets of data at the same time. This is what we say double bar graph. Now, how to organize a data? What is meant by organizing a data? So, if you have a raw data, it may be difficult to analyze the data. So, then we can organize that into some groups. That is what we say organizing data. Let me give you one example. Suppose this is the data related to the blood groups of the students of your class. Now, if you observe directly this data, it may be difficult to analyze this data. So we can show this data in the form of a table. Let me construct the table. First write blood groups. Then tally marks. Then number of students. Let us draw the table. So like this. Now what are the blood groups we have? A, B, AB and O. These are the blood groups we have. Tally marks means just we put some vertical bar to represent an entry. Suppose if we take A, here cross out A here and put one bar like this. Now observe, is there any A? So here is A and then put a bar like this. Now again here we have, so put one more bar, vertical bar. So here A, now we can put a bar. Now after that you cross out next A and then make the group of these bars like this. So how many bars are there? 1, 2, 3 bar. This cross bar is 1. So total 5. Now let us write number of students equal to 5 here in the number of students column. Similarly, if you take B, cross out one B here, put one vertical bar here. Now cross out the next B and put a vertical bar. Next B and vertical bar. Next B and vertical bar. Next B. So here 4 bars are completed. For the next B, that means for fifth B, let us draw a cross line like this. Now next B, cross out the next B and put another vertical bar like this. Then you have one more B here and put one vertical bar, one more B here. So the total 5 here and 3 here, total we have 8 number of students. Now let us go to AB. So how many ABs are there? 1, 2, 3. So put 3 vertical bars here, write 3 here. Now how many O's are there? You see 1, 2, 3, 4. So put 4 vertical bars like this and write 4 here. Here how many students have blood group A? There is 5. That means in this data A occurred 5 times. That is what we say frequency. Frequency of A is 5. How many times A occurred? That is what we say frequency of A. So in general, in a data, how many times an observation occurred? That is what we say frequency. Now this table shows the frequencies of A, B, AB and O. This table shows the frequencies of different blood groups A, B, AB and O. So this table is called frequency distribution table. That is what is meant by frequency distribution table. Let me take one more example. Suppose your math teacher conducted an exam for you for 50 marks and noted down the marks. The marks are like this, suppose. Now to organize this data, we can form this into groups. We can frame a frequency distribution table. Here you see, let us write groups here. Groups means we can say them as classes. Then tally marks. Then number of students. So here classes means we can form some groups like from 0 to 10, then from 10 to 20, then from 20 to 30, 30 to 40, then 40 to 50. Like that we can frame some groups. So here 0 to 10 means how many students got the marks in between 0 and 10. Let us see. Here in the first row, no student got the marks in between 0 and 10. In the second row, one student got 9 marks. So put one tally mark here. Then is there any student? No. So that is why number of students who got 0 to 10 marks is 1. Now 10 to 20. In the first row you observe one entry is there 17. So put one tally mark here. And then 15 is also there. So put one tally mark here. In the second row we have one 14 which is in between 10 and 20. Put one tally mark here. So that's it. So how many students got the marks in between 10 and 20? So 3 students. Now 20 to 30 you see there 20 to 30. So 23 is there in the first row. Then in the second row 26 and 27 is also there. So how many students are there? 3 students. So write 3 here. Now check how many students got marks in between 30 and 40. So first number is 40. Now here the question arises, 40 becomes to which group? Whether to 30 to 40 group or 40 to 50 group. So there is a confusion. To avoid this confusion, mathematicians made one convention that whenever we have a situation like this, then mark the entry in the upper class. That means instead of writing the 40 in 30 to 40 class, mark 40 in 40 to 50 class. So 40 belongs to this class 40 to 50 class, not for 30-40 class. So in the first row, the numbers between 30 and 40 are, one is 39, just 1. Then in the second row we have 33, so put 1 mark here. 35, put 1 mark here. And 30 to 40, here is 37, put 1 mark. For 38, so 4 over and fifth one, to write fifth one, draw a cross line like this. And that's it. So 30 to 40, how many? 5. So here we did one mistake actually. You see that 29 is there. We need to put this in 20-30 class. So here. So this is not 3, this is 4. Now let's go to 40-50 class. So 1, 2, 3, 4, 5, 6 are there. So 1, 2, 3, 4, 5 and 6. So then 6 is the number of students. Now to write this 50, we need to write one more class actually. So 50 to 60, 1 tally mark here, and number of students is 1. This is called frequency distribution table, and here we made some groups. So those are said to be classes. So this is said to be grouped frequency distribution table. This is what we say, grouped frequency distribution table. Here these groups are called classes. Suppose if we take 0 to 10, this is a class. In this one, the lower value, this is said to be lower limit. Lower limit. This 10 is called upper limit. This is called upper limit. Now the difference between any two successive upper limits. So here for 0 to 10 upper limit is 10, and for 10 to 20 the upper limit is 20. So the difference between these two, that means 20 minus 10, which is equal to 10. This is called, this value 10 is called class width. Class width or class size. So class size or class width means the difference between any two successive upper limits, or we can take any two successive lower limits also. Sometimes it is called as class interval also.